Welcome to this explainer. I want you to imagine, just for a second, a substance that is exactly like the normal matter that makes up you, me, the device you're using right now, and, well, everything else we see in the night sky. It has its own atoms, its own particles, and it can even form recognizable things like antihydrogen. But there is one absolutely explosive catch. Upon contact with regular matter, both sides are instantly annihilated in a blinding, perfect flash of energy. Now, I know that sounds like pure blockbuster science fiction, doesn't it? But it's actually a fundamental, proven part of our reality. Antimatter is found in deep underground laboratories, in cosmic rays raining down from space, and, believe it or not, even in your local hospital. So, what exactly is it? And why does our universe seemingly prefer regular matter? Let's dive in.
So what if a literal mirror version of our world actually existed? Pop culture loves to portray antimatter as this evil twin, right? Like some dark doomsday weapon just waiting to be unleashed. But honestly, the scientific truth is so much more fascinating than the movies. It's not an evil twin at all. It's simply a mirror reflection that happens to be fundamentally incompatible with our world. You see, when matter and antimatter meet, they don't just break apart into smaller pieces, like two cars crashing. No, they completely erase each other from physical existence.
To wrap our heads around this, we need to look at the basic building blocks of everything around us. Everything consists of particles, electrons, protons, neutrons. But for nearly every particle making up our reality, the universe has minted an exact mirror twin. And when physicists say mirror, they don't mean it looks backward in a physical glass. They're talking about its quantum properties. An antiparticle has the exact same mass and the exact same spin as its regular counterpart, but it carries a perfectly opposite electrical charge. Take the electron, which has a negative charge. Its antimatter twin is called the positron. It's identical in every single way, except it has a positive charge. The twin of a positive proton, a negative antiproton. They are perfect opposite reflections.
But here is where it gets crazy. This isn't just happening in billion-dollar laboratories or out in deep space. In fact, you can probably find antimatter sitting right there in your kitchen. The potassium-40 in your everyday, ordinary bananas naturally undergoes a tiny bit of radioactive decay, and when it does, it literally spits out naturally occurring positrons. Those tiny antimatter particles instantly collide with the normal matter inside the banana and just vanish. But for a fleeting fraction of a second, you actually have real, genuine antimatter right there in your fruit bowl. It's a completely natural phenomenon.
To really grasp why this happens, we have to look at the very fabric of space through the lens of quantum fields. Modern physics tells us that the universe isn't just a collection of solid objects floating around in an empty void. Instead, space is filled with these invisible fields that stretch across the entire cosmos. And, as theoretical physicists point out, antimatter isn't some weird cosmic mistake. It is the inevitable, unavoidable reverse side of any quantum field. You simply cannot have one without the potential for the other.
Let's think of a quantum field like a perfectly calm, flat ocean. When you throw a burst of energy into this ocean, it creates a ripple. The upward crest of that wave popping out of the water is what we perceive as a regular particle of matter. But think about it. You physically cannot have an upward crest without simultaneously digging out a downward trough in the water right next to it, right? That exact mirror trough is the antiparticle. They are perfectly complementary, completely inseparable parts of the exact same field, created together by the same burst of energy. Which brings us to the famous concept of annihilation. When that wave crest of matter and that wave trough of antimatter eventually meet again, they don't blow up like a stick of dynamite. In a normal chemical explosion, only a tiny, tiny fraction of the material actually turns into energy. The rest just scatters as debris or smoke. But with annihilation, the wave and the trough simply flatten each other out completely. The ocean returns to a calm, flat state. But the mass doesn't just disappear. 100% of their combined mass is converted directly into pure energy, usually in the form of photons or light. This is Einstein's famous E equals mc squared equation playing out in its purest, most absolute form. To really put the sheer scale of E equals mc squared into perspective, this perfect annihilation releases an energy density 300 times greater than the nuclear fusion happening right now inside the incredibly hot, dense core of our sun. Let that sink in. It is the absolute maximum limit of energy conversion permitted by the laws of physics. There is literally no more efficient way to generate energy in the entire universe. It's nature's ultimate energy release. what's truly amazing to me is the incredibly short leap from pure theoretical math on a chalkboard to physical reality. Back in 1928, physicist Paul Dirac was simply trying to write down an equation to describe the electron, but the math wouldn't work unless it demanded the existence of a mirror particle. The numbers literally pointed to a reality no one had ever seen. Just 4 years later, in 1932, Carl Anderson physically discovered that exact particle, the positron, raining down in cosmic rays. Fast forward to 1995, and scientists at CERN successfully synthesized the very first complete atoms of antihydrogen. Theoretical math beautifully and perfectly predicted our physical reality. But of course, successfully creating it immediately introduces a seemingly impossible engineering nightmare. Think about it. If antimatter completely annihilates upon contact with literally any physical matter, how on earth do you store it? You can't just pop it in a glass jar, a steel tank, or a titanium vault. The very millisecond it touches the walls of any container, the antimatter is completely gone, taking a chunk of the container with it.
So, the brilliant minds at CERN have to treat this like the ultimate high-stakes physics heist. First, they create antiprotons inside an absolute perfect vacuum, ensuring there is zero stray air floating around for it to hit. Second, they have to drastically slow down these incredibly energetic antiprotons using a complex system of magnetic brakes. Finally, they suspend the fragile antimatter in what is called a penning trap. This is a highly complex, invisible web of electromagnetic fields that holds the antimatter completely frozen in mid-air. It just hovers there in the vacuum, completely untouched by any physical wall or container.
And get this, recently, researchers at CERN's base step experiment took this delicate balancing act and essentially accomplished the impossible. They managed to transport 92 incredibly fragile antiprotons 8 kilometers entirely across their massive facility. But here's the kicker. They did it in a portable magnetic trap loaded inside a regular, moving delivery truck. Think about the stakes there. If that truck hit a pothole, or if the magnetic field wavered for even a fraction of a second, the antimatter would have instantly touched the side of the container and vanished. But the engineering was so perfect, they pulled it off without a single hitch. This incredible level of control also recently settled a long-standing science fiction debate: anti-gravity. People always wondered, if antimatter has an opposite charge, does it fall up instead of down? Well, the ALPHA experiment at CERN carefully released a few suspended atoms of antihydrogen just to see exactly how gravity pulls on them. The result? It falls downward at exactly 9.8 meters per second squared. It falls exactly like normal matter. So, unfortunately for all the sci-fi fans out there, anti-gravity is officially debunked. Gravity pulls on mass, and antimatter has the exact same mass as regular matter. But let's bring this out of the theoretical physics laboratory and right into your everyday life. You might not realize it, but antimatter isn't just some abstract concept for scientists in white coats. It is already practically applied and literally saving lives in your local hospital right now. Have you ever heard of a PET scan? It stands for positron emission tomography. They literally use antimatter to peer inside the human body. Doctors inject a very safe, mildly radioactive substance into a patient, a substance that naturally emits positrons. When those tiny antimatter positrons meet the regular matter electrons naturally occurring inside the patient's tissue, they undergo a safe, controlled annihilation. This creates tiny harmless photons of light inside the body. The scanner forms a ring around the patient, detecting these exact flashes of light to create incredibly accurate, real-time maps of internal bodily processes. We are already harnessing quantum annihilation every single day to detect diseases. Now, looking toward the far future, the potential applications for deep space exploration are completely mind-bending. Because annihilation perfectly converts 100% of mass into energy, a rocket engine powered by antimatter would be unimaginably potent. It could theoretically convert about 70% of that raw explosive energy into direct spacecraft thrust. We are talking about revolutionary interstellar travel, where reaching the nearest star systems would take just days or weeks, rather than centuries of slow, agonizing drifting. So you're probably wondering, why aren't we flying antimatter rockets right now? Well, there is a massive inefficiency barrier standing in our way. 1 billion. Currently, with our level of technology, creating antimatter requires about 1 billion times more energy than you actually get back from it when it annihilates. Producing even a single microscopic gram of antihydrogen would cost trillions upon trillions of dollars and require astronomical amounts of electricity. It is simply too difficult and far too energy intensive to manufacture in large usable quantities right now. Which leads us to the ultimate, existential mystery of this entire explainer. According to the strict laws of quantum physics, the massive energy from the Big Bang should have created exactly equal amounts of matter and antimatter.
Remember the calm motion analogy? Every single wave crest should have a wave trough. But if that happened perfectly, all the newly created matter and antimatter should have completely annihilated each other in the very first moments of time. The universe should be vast, empty, and filled with absolutely nothing but light. Theoretically, it should have been a perfect 50-50 split. But as the observed reality of our universe clearly shows, regular matter somehow won the cosmic war. I mean, we exist. For every 1 billion pairs of matter and antimatter that violently annihilated each other in the early universe, exactly one extra particle of regular matter somehow survived. That tiny 1 in a billion imbalance is literally the only reason the galaxies, the stars, the Earth, and you and I are here today. Scientists are desperately searching for the cause of this grand imbalance, a puzzle known as baryon asymmetry. And one thrilling possibility is called the Majorana mystery. Researchers in deep, heavily shielded underground labs are trying to figure out if certain elusive ghost-like particles, called neutrinos, might actually be their own antiparticles. Imagine a coin that has heads on both sides. If a neutrino can flip between being matter and antimatter, it might have cheated the system during the Big Bang, creating just slightly more matter than antimatter. If true, this unique little quirk could finally explain the exact mechanism that tipped the cosmic scales. So we are, quite literally, the universe's billionth mistake. We are the surviving debris of a grand cosmic annihilation. Antimatter shows us that math can perfectly predict reality, that mass and energy are entirely interchangeable, and that the universe is far stranger and more delicate than we ever imagined. It leaves us with an incredibly provocative question. If this entire mirror world was hiding in the math all along, just waiting to be found, what else is out there? What other secrets are written into the very fabric of reality? If you want to keep exploring how the universe is built and diving into these grand mysteries, make sure to subscribe to Code of the Universe and keep learning. Thanks for joining this explainer.